Determine the sum to infinity of the following infinite series. Let us begin. So here we have an infinite series, and it's neither an arithmetic series nor a geometric series. It's not an arithmetic series because it does not have any fixed common difference. We can take any term and subtract the previous term from it. That's not going to stay the same. And also it's not a geometric series because it does not have a fixed common ratio. However, this particular series is composed of a arithmetic series and a geometric. It's composed of an arithmetic sequence and a geometric sequence. To understand how it's done here, we are going to rewrite each of the terms. We can rewrite the first term as 1 multiplied with 1 added to the second term, which is 5 over 2. We can rewrite it as 5 multiplied to 1 over 2 added to, we have 9 over 4. We have 9 multiplied to 1 over 2 squared. And the fourth term, we can rewrite it as 3 multiplied to 1 over 2 cubed. So this goes all the way up to infinity. Now here, the terms, if we consider 1, 5, 9, 13, but we can see here that these four terms and the four subsequent terms, these are in arithmetic progression because they have a fixed common ratio. And then we have 1 half, 1 over 2 squared, 1 over 2 cubed, and these terms are going to be in geometric progression, and because it has got a fixed common ratio, are given by 1 over 2. Now what we'll do, we will try to find out the sum. For this, let us suppose that let S infinity, that represents the sum to infinite number of terms of the series 1 plus 5 over 2 plus 9 over 4 plus 13 over 8. And this goes all the way up to infinity. Then we're going to take the sum up to the infinite number of terms and multiply each terms with the common ratio of the geometric progression, which is 1 half in our case. We have 1 half of S infinity. So we're going to take half and multiply with each of the terms. So half times 1, that's 1 half, but we're going to write it below 5 over 2. Then we're going to take the second term, 5 over 2, multiplied with 1 half to get 5 over 4. Then we have 9 over 4 multiplied to 1 half, that gives us 9 over 8. And this is going to continue. Now what we'll do, we're going to perform a subtraction here. So we'll take S up to infinite number of terms, and from here subtract half of S up to infinite number of terms. So the first term that stays is 1. Then we have 5 over 2 minus 1 over 2, that comes to 4 over 2. Added to, then we have 9 over 4 minus 5 over 4, so that's 4 over 4. Added to 4 over 8, and this is going to go on all the way up to infinity. Now on the left hand side, we have half multiplied to S up to infinite number of terms, that's equals to 1 added to. Now here, what we have here is a infinite geometric series. An infinite geometric series, the sum of the infinite terms, that's given by A over 1 minus R. Now in this particular case, the first term A, which is 4 over 2, 4 over 2 is simply 2, divided by 1 minus the common ratio. So if we take the second term, which is 4 over 4, that's simply 1, and divided by the first term, that's 4 over 2, which is 2. That means our common ratio comes out to be 1 half. So this is simply 2 divided by 1 half. So that means the sum up to the infinite terms of the geometric series, that comes out to be equals to 4. Now that means the summing up to infinite series of the original sum, so that comes out to be equals to 4 plus 5, that's 5. 5 multiplied to 2, that's 10. So that means the sum is 10.